Well, hello and welcome to a Robolink drone tutorial. So today we're going to be covering how to program the controllers, or not the controllers, but rather the joysticks that you have with your drone. Um, these joysticks are analog sensors, meaning that they have a range between some number. Whoa. All right. Meaning that they have a range between some number to another number, usually 0 to 1023. And so we're going to be using these devices, or this, in this case, these joysticks, in order to give inputs to our drone or give commands to our drone. So depending on how I move the joystick, it can mean that the drone is going to go forward or it's going to go backwards. So that's the intention of this video. Like always, adding the setup and the loop. Setup, the majority of this video setup is going to be uh, stupidly simple. The same for, I believe, most of them, unless I decide to do a special device or something. We have the serial begin, because that's how we're sending the information to Zigbee. We got to establish that we're going to open that channel. Smart drone control, set up everything that the drone's going to be using, uh, any pins and devices that need to be initialized, and delay so that it has time to do all this. Um, Yeah. So, as I said, you can program. The idea is you're programming a remote more or less, or you're programming the device that is telling the drone what to do. So if you're clever enough, or you have an idea, you can program different devices. You can program IR sensors, ultrasonic sensors, and depending on whatever setup you have, you can make the drone react accordingly. So that being said, we are gonna stick to the use of our uh, joysticks. Now, these joysticks are they're pretty simple. They work the same way well, not the same way, but they work in such a way where if you leave the joystick without touching it, it's zero. No, that's not true. Sorry. If you touch the joystick backwards, it's zero. If you touch the joystick forward, it's its maximum, which in this case is 1023. There we go. But that in itself is an issue because, um, real quick, I have lesson here, uh, lesson for one, because this is going to disable the controllers. And then we're going to have state equals fly. This is what we're checking so that we can operate the drone in our own terms and it doesn't just automatically try to fly away from us. That being said, I go back to what I was saying before. The fact that the joysticks don't give you a number between negative 100 and 100 is an issue. And the reason it's an issue is because it means that we cannot use the number directly. We have to convert it. We have to scale the number. Get it? That's the name of the function that I'm about to use, scale. We got to scale the number into something that we can use. So we got to change it between 0 to 1023 to negative 100 and 100. Now, in Arduino, you can do a function called map that will do it for you. We have our own function that does pretty much that. Uh, it's called smart drone. So all our functions are going to have smart drone control in front of it, followed by a period. And this one is analog scale change. Now, analog scale change does exactly what I'm describing. It takes a value that you feed it, and it turns it into a number range that we need, which is negative 100 and 100. Now, the problem with, well, not the problem, but the deal with this is numbers between negative 10 and 10 get automatically zeroed out. Now, the reason why it does that is because we don't want our throttle, or we don't want our drone to start flying just because of the tiniest of nudges. So we ensure that there's going to be a neutral zone where the drone is not going to move by accident. So that being said, we have to uh, make sure that our input device can go greater than that range. So if you have something that can only go between 0 and 1, you would have to get clever with how you would do this. Maybe multiplying by a number or adding a number to it. Now, what we feed it is what device, where your device is connected, and a way to read it. So when we do analog read, we connect or we make a call into that location, which is in this case A3. For the Smart Inventor board, that's the equivalent of pin 22. And what does that is it reads that device, and then it's fed into this other function, which then changes the value range that it will be. Now, depending on where your device is connected, you will uh, change the numbers inside. So A3, A4, A5, and A6 are because that's where my joysticks are connected, and so I am going to keep it that way. If you happen to connect it somewhere else or you need to do something like that, you just change the number in here. So recap, analog change changes the range of your input devices. Now, I have now something for throttle, yaw, pitch, and roll. So when I change these sensors, they will cause the drone to do something, right? So consider I do have the drone has to be on them. Now, again, you have to send that information to your drone. So writing it here is not good enough. We have to tell the drone and let him in the loop. The way we're gonna do that is we're gonna again send that information. However, we're gonna use a slightly different send than the one from the initial or video one, and that one is gonna be interval send. Now, it would be pretty annoying if somebody is constantly yelling at you to do something. So you would rather be told over time or in a span of time rather than constantly nonstop. We want to send information over to the drone so that we make sure that it gets it, but we want to have it be able to do stuff with that information before we send it more. So we're gonna be sending these packages with what these are supposed to be in intervals, right? So hence the name of the function being interval send. So this function takes in an input, uh, meaning milliseconds, I believe, is the time that it takes. So you can put a number, and that's how long it will wait before sending it again. The default time that we put here, the send interval, is 20 milliseconds, I believe. So this will ensure that every 20 milliseconds, information gets sent to the drone. So not too fast for in terms of the computer, really fast in our eyes. Um, but yeah, with this code, considering that you have everything set up to fly, and you have pair your robot and your controller, you will be able to fly your drone using the joysticks or any other device. So, hopefully this was helpful. If you have any comments or any questions, feel free to contact us and tell us. That way we can improve and make these even better. So, thank you for watching and have a good one.